are done with the exercise, let us go over the answers together. So, the first one there, it says there 3x. The first term is 3x. Let me go and look for all of my x's. There's a 3x there, and there's a 4x there. Are there any more x's? No. So let me add. 3x plus 4x is equal to 7x. Done. Next term, I've got 2x squared, and I've got plus x squared. What is plus 2x squared plus x squared? What number is here that we don't write down? Very good. There is an imaginary 1. If you want to write it, if you don't want to write it, it doesn't matter. Generally, people don't write that plus 1 because we take it for granted that there is a positive 1 in front of a base that doesn't have a coefficient. So, plus 2 plus 1 gives us plus 3. Bring down your x squared. Let's see. Do I have any more terms here? I've got the minus 4. And the minus 4 doesn't have any more terms to be added to. So, that is your final answer. But, you can see that I stopped there. Because something doesn't look right in this algebraic expression here. Something looks odd. What looks odd about it? Very good. The algebraic expression is not in the correct order. If you look at your maths textbooks, you will see that they always organize these algebraic expressions in decreasing powers of x. So how I should actually write this down is I should put my highest power of x first. I put my x squared first. Then there's my x to the 1. I write that secondly. And finally, I write the minus 4 down. Basically, that last step there isn't about adding and subtracting anything. The last step here, kids, is just to put this algebraic expression in the correct order. It's just to make it look mathematically correct. But this answer is, in fact, right. Then, if we go over number 2. Number 2, the first term here is 16a. So let me look for all of my a's. 16a, there we go, minus 3a. What's 16 minus 3? 13. A. Then I have my b's. Plus 2, plus 7, plus 9b. That was a straightforward one. Very good. If you look at the third example here, now we have A, B's and we have A's. So what? It doesn't matter. It doesn't matter. If I have the base A, B here, remember I am looking at the bases that are next to the coefficients. I'm looking for base A, B. It doesn't matter. I've got plus 2AB here. I can't use that. There's another AB there. Let me add those two, or subtract those two. What's plus 2 minus 6? Minus 4. And you just bring down your AB, just like we've been doing all the time. We're just bringing down the same base. It doesn't matter if it's A, B, C, X, Y, Z. If there is some other term that has A, B, C, X, Y, Z, you are free to add and subtract it to the corresponding term. Let me look here. Now I have an A. I'm looking for A's. So I have plus 4. There's it there. Minus A. What is written in front of this A? Very good. There is an imaginary 1 there. So plus 4A minus 1A is going to be plus 3A, because we're just going 4 minus 1. And if I go through my sum, look, this guy doesn't have a friend. It doesn't have any other B to add to. You can't just ignore it. What you got to do? Bring it down exactly as it is. And that is where ticking off terms actually helps you. Because if I had not ticked off my terms, I probably would have forgot this 2B there. So it's always nice to tick off. Use a little pencil if you want to. And then you can bring down the term that doesn't have any French to be added or subtracted to. If you look at the last example. So now we will move on to multiplication of algebraic expressions. So when it comes to multiplication, we know that to represent multiplication, we can use a multiplication sign as we've been doing in primary school. Or now that we're getting older, we can now use brackets. Brackets means that you are going to multiply. So for all of my work, I am going to tend to use brackets because we're in high school now. So when it comes to multiplying algebraic expressions, we are going to go sign, coefficients, base. Every time I am multiplying, I am going to go sign, coefficient, base. Because when we are going to multiply these algebraic expressions or longer algebraic expressions, it can get a little bit confusing. So when I'm multiplying, I'm first going to multiply the sign, then I'm going to multiply the coefficients, and then I'm going to multiply the base. So let's look at the first example, very, very easy example. So we're going to multiply the sign, coefficients, and the base. So here you have 4x times minus 2. Let me look at the signs. Positive times a positive is going to give me a positive. Coefficients. 4 times 2 is going to give me 8. And my base, I just bring down my x. My answer there is 8x. Very, very straightforward one. Let me look at the next one. Multiply my signs. Positive times a positive, I'm going to get a positive. 4 times 2, I'm going to get 8. Base, x times y. So x and y, they are unlike bases now, so we can't do much with them, but we can just put them next to each other. So x times y is xy. A times b is ab. M times p is mp. So where you have unlike bases, you can't do anything with them, you're just going to put them next to each other. Let's look at the next one. And here, let me change the question up. Let me make this a minus 2. So, if we go sign, coefficients, base here, a plus times a minus is going to give you a minus. 4 times 2 is going to give you 8. Last one is my base. X times x. What is x times x, kids? X times x is actually x squared. And that ties in with the one of the laws in exponents. Let me go over that law here. So, if you have x cubed times x squared, if you have like bases, your x and your x, your base is going to stay x. But what are you going to do with your exponents? You do not multiply your exponents. When you multiply like bases, you are going to add your exponents. So we're going to say here 3 plus 2 is going to give me 5. When you multiply like bases, you are going to add the exponents. Let me do another one. If you have y cubed times y squared times y to the 4th. The base is y. And you're multiplying, let's add the exponents. 3 plus 2 is 5 plus 4, y to the 9. So this has to go with the first law or the multiplication law in exponents, and it is covered in a separate video. So, let us carry on with the sum now. So if we're going to carry on with the sum here, or if you have to go back to the sum, we said a plus times a minus gives you a minus. Coefficient, 4 times 2 gives you 8. Base, there's my x. And we said that when we're multiplying like bases, we're going to add the exponents. So There's my imaginary one, and there's my imaginary one. If you're scared, kids, you go and write your 1. It isn't wrong. And now we can say, since we're multiplying 1 plus 1, that is how we got the exponent 2. Very good. Let's look at this last one here. And again, I'm going to change the question, make it more interesting. I'm going to make that a -4, and I'm going to make that a -2. So Mia has a lot of bases happening here. Let's go together. Sign coefficients base. A minus times a minus gives you a plus. When you multiply like signs, like a minus and a minus, a positive and a positive, you are always going to get a positive answer. The way that I remember it is that if you like somebody, you have positive feelings toward the person. You can remember it any way you want. But if you like someone, you have positive feelings toward them. So naturally, if you're going to multiply like signs, you are going to get a positive answer. Sign. Coefficients. 4 times 2 gives me 8. And look, I have x's and I have y's. So let me work with my x's separately first. What's x squared times x squared? You're going to say 2 plus 2, and you're going to get 4. Let's work with the y's. What's y squared times y? I'm writing my 1 because I can. What's y squared times y to the 1? Y cubed. Done. So when it comes to multiplying algebraic expressions, kids, you can break it down very, very simply when you're starting off so as not to get the answer wrong. What you're going to do first is you're going to multiply your signs, then you're going to multiply your coefficients, and then you're going to multiply each base separately. When you are multiplying like bases, you are going to add exponents. That's the first law of exponents that is covered in a separate video. So what I'm going to do now is I'm going to give you a few examples. You are going to work through it and we'll go through it together.